great question, and it is multifactorial. So I think first is what I already talked about. Natural immunity is not protective. And so that sort of tenet of making people who have never been infected with the vaccine look like someone who has, being a solution, is not going to work for CMV. You talked about the large size of its genome, and the way it incorporates new genes through its millions of years of evolution means that it has evolved and even probably captured from even our genomes strategies to evade immunity that are more extensive than any other viral pathogen. And so it is very good at, again, reinfecting when you have immunity, and evading some of the critical things we try to induce through vaccination, antibodies and T cells. So that is a part of it. Also, its large genome means it has devised different ways to enter into cells, which is often the target of vaccines, to elicit neutralizing antibodies that will prevent the virus from entering a cell. Well, CMV has a number of ways that it does that. In fact, it has 14 different immune complexes or glycoprotein complexes on its surface, and it uses a combination of those to enter cells. And so unlike SARS-CoV-2 that had just the spike protein we had to worry about, HIV envelope is all we think about, RSV-F, of course there's an RSV-G, but it was a limited number of proteins to think about. CMV has a number that could be considered. And then I do think just the lack of recognition of this infection. Only 9% of women, when polled, who are of childbearing age, know about this virus. And so I don't think it's gotten the attention from the public. It has not gotten the attention from the funders. It's not gotten attention from even the scientists that this is a problem they should be focused on. And I think that's held the field back. But the good news is that the vaccine manufacturers have seized upon it as the next really important project that they are focused on. And so luckily there are a number of commercial programs to develop a CMV vaccine now.